Welcome to Actuate Biomedicine's Biomedical Knowledge Translation Faucet. Our mission is to bridge the gap between scientific research and practical healthcare applications, ensuring that the latest advancements improve patient care, health outcomes, and public health. Biomedical knowledge translation involves turning cutting-edge biomedical research into tangible solutions for healthcare systems. At Actuate Biomedicine, we specialize in this process, ensuring that scientific breakthroughs reach those who need them most. We host our Learn to Earn sessions every Tuesday from 7 p.m. to 8 p.m. East African Time. Each cohort participates in an 8-week program designed to guide learners through the 7 stages of biomedical knowledge translation. The 7 stages include exploration, where we identify new research and innovations; evaluation, assessing the potential impact and feasibility; planning, developing strategies for implementation; development, creating practical applications and solutions; implementation, integrating these solutions into healthcare settings; another round of evaluation, monitoring and assessing effectiveness; and finally, distribution, ensuring wide access to the final products. Our learners gain in-depth knowledge and practical skills, empowering them to translate biomedical research into real-world applications. Through our program, we aim to foster a new generation of experts who will drive advancements in healthcare. Join us at Biomedicine's Biomedical Knowledge Translation Faucet. Together, we can make a significant impact on healthcare and public health. Learn, earn, and contribute to a healthier future. Be a part of the change. Transform knowledge into action with Actuate Biomedicine. Welcome to Actuate Biomedicine's Biomedical Knowledge Translation Faucet. Our mission is to bridge the gap between scientific research and practical healthcare applications, ensuring that the latest advancements improve patient care, health outcomes, and public health. Biomedical knowledge translation involves turning cutting-edge biomedical research into tangible solutions for healthcare systems. At Actuate Biomedicine, we specialize in this process, ensuring that scientific breakthroughs reach those who need them most. We host our Learn to Earn sessions every Tuesday from 7 p.m. to 8 p.m. East African Time. Each cohort participates in an 8-week program designed to guide learners through the 7 stages of biomedical knowledge translation. The 7 stages include exploration, where we identify new research and innovations; evaluation, assessing the potential impact and feasibility; planning, developing strategies for implementation; development, creating practical applications and solutions; implementation, integrating these solutions into healthcare settings; another round of evaluation, monitoring and assessing effectiveness; and finally, distribution, ensuring wide access to the final products. Our learners gain in-depth knowledge and practical skills, empowering them to translate biomedical research into real-world applications. Through our program, we aim to foster a new generation of experts who will drive advancements in healthcare. Join us at Actuate Biomedicine's Biomedical Knowledge Translation Faucet. Together, we can make a significant impact on healthcare and public health. Learn, earn, and contribute to a healthier future. Be a part of the change. Transform knowledge into action with Actuate Biomedicine. Welcome to Actuate Biomedicine's Biomedical Knowledge Translation Faucet. Our mission is to bridge the gap between scientific research and practical healthcare applications.
biomedical engineer students going to check us today. So I'm going to give Dr. Masharia.
Grace, I think you're having a problem with the network. I don't know why it's not connecting. We're hearing some words, but not others. Hello?
Hello.
Oh, I think you have serious network issues there. Mm-hmm. I don't know. Try again. No, Grace, that network is not good. Coming with a lot of static, and we are hearing almost nothing. Maybe you can log out and log in again. See if it's going to help. Or you check the network. I don't know, because the network depends on network. Some networks are inefficient.
Hello, Doc. Hello, good evening. Can you hear me?
That sounds clear. Hello?
Maybe she can continue to work on my network. Hello, Jamila.
All right. So what did you say? Did you ask Jemima to start speaking? Oh, Grace. I don't know. So anyway, I didn't get what Grace said there, but I think Grace has invited Jemima to speak. Is Jemima our topic master today?
Yes, Jemima is our topic master. She can continue.
All right, go ahead. Yeah, now that's clear. What did you do?
Hello everyone.
Oh, hello, Jemima.
Hello Daktari. I am glad to be back. I am Jimmy Wambui, but so today we are going to talk about biomedical engineering. Let me share my screen.
Yes, could you speak louder? Then I'm increasing volume. Hey, what's going on with the network today? Jemima, we can't hear you. Or did you stop speaking?
Hello. Can you hear me now?
Yeah.
Okay. Let me share my screen.
Okay.
So yes, I am Jemima Wambui. I am glad to be back, and today we're going to discuss about biomedical engineering and its role in improving healthcare. So biomedical engineering is a disciplinary field that combines engineering, biology, and medicine to develop technologies that improve healthcare. So it uses principles from electrical engineering, from mechanical engineering, and chemical engineering, alongside the medical sciences to address complex health challenges. So, for example, like me, in my first year and second year, even partly that year, I was majoring in electrical engineering. So you do a lot of units in electrical engineering, and then you go to medicine where you start doing units such as anatomy and physiology, so that you can understand the medical sciences, and you build projects that integrate everything that you have learned in your final year. So engineering being the art of solving problems, we then apply it in medical problems so that we can get the medical technology. So some of the core areas of biomedical engineering are medical devices development, where you create and build devices such as the MRIs, the X-ray machines, prosthetics for prosthetics and other devices. We also have biomechanics, which involve the study of the human body, the human body in terms of its mechanical aspects. We also have medical imaging, which is the development of imaging technologies for diagnosis, technologies like the X-ray, the MRI, which you use to take a closer look inside the human body. We also have digital health, which focuses on health informatics, that is IT in health, to develop technology such as telemedicine, and also to manage patient data. We have biomaterials, which is the study of matter as it interacts with biological systems during surgeries, for medical purposes, like in diagnosis, maybe in treating a person, and in surgeries, or even replacing damaged organs and damaged tissue. We also have advanced specialization like tissue engineering, which focus on creating and regenerating biological tissues to replace damaged ones. So biomedical engineering, as I said, it is a vehicle towards improving healthcare, and it has unique ways of solving medical problems that is not available maybe in other fields. So we're going to discuss some of the unique problem-solving elements in biomedical engineering, which number one is the interdisciplinary nature. Biomedical, because it involves multiple disciplines, we blend the principles from each discipline so that we can create solutions which are technically precise and also biologically compatible. So we bring in a biomedical engineer is able to manage a team of medical doctors, of other engineers like electrical engineers, mechanical engineers, and even other caregivers, so as to come up with a unique solution for a problem in medicine, that is. So another element that it has is also it has human-centric design, which means it deeply focuses on the human experience, meaning those solutions must not only work, but it has to adapt to the needs of the patient. It has to adapt to the environment where the patient lives. And if there is any change, maybe if the patient is used to doing, maybe if the patient is an athlete, the medical solution should be catering for that. If the patient is maybe a person who sits down a lot or is not as active, the solution should be effective for that particular person. So it focuses also on the human experience, and it's not the tech. It involves just the technical part, but majorly it has to cater for the human experience as well. So number 4, we have innovations in minimally invasive technologies. Biomedical engineers often work on tools and techniques that make procedures less invasive, which reduces recovery time, it lowers infection risks and cases. So equipment such as the laparoscopic surgery equipment is used to perform surgery on people, but we are not cut open, so it is minimally invasive. We also have biomedical engineering aims to provide data-driven healthcare solutions. This is where you use real-time data and you analyze them to inform on better healthcare decisions. So we develop wearable sensors and monitoring systems that allow doctors to monitor patient health trends wherever they are. So for the future, this means that one can prevent illnesses, making healthcare to be more proactive for already healthy people. So I personally chose biomedical engineering for this reason. Not only can you cure or treat illnesses, you can now prevent illnesses for like the healthy people. And so it makes us adapt to healthy lifestyles more easily. For example, if you only have like a watch which reminds you to drink water at a certain time, it makes you adapt to a healthy lifestyle. So you're preventing the illness before it even comes. And I also love biomedical engineering because of its element of scalability. Scalability is where you are able to solve you are able to create one device or a software which solves problem for several people at the same time, or even cuts down on the need of a personnel in order to get medical services. So unlike the traditional medicine where one person treats, that is a doctor or a nurse or a caregiver is treating one person at a time. So we are building solutions that can serve entire communities or even regions. So having the diagnostic equipment such as an MRI, for example, it can diagnose up to 100 patients weekly, which if it's done by one person, it can't be possible. We also build remote patient monitoring tools that integrate the data from medical devices, it analyzes the data and transmit them so that we can make telemedicine possible. Telemedicine, which eliminates the problem of geographical barrier. So these are some of the reasons why biomedical engineering is unique to solving medical problems. We also have customization and personalized medicine as a result of applying these principles. And also we build solutions that are environmentally friendly and also cost effective. So using biomedical, these principles has brought a lot into the world. We have so many devices and systems, and we are even progressing further. I'm just going to read through them. We have medical imaging devices, the X-rays, we have artificial organs and prosthetics. Even we have like, you can be operated on using a doctor from another country can operate on you using principles in robotics. We have minimally invasive surgical tools. We have wearable health monitoring devices. We have also regenerative medicine and tissue engineering. We have medical implants, drug delivery systems, which you can use as a patient independently. So that means they have made it easier, and you don't need a person so that you can be able to administer drug to yourself. And we also have remote patient monitoring. So those are some of this is an overview of medical engineering, and I'm glad to have spoken on it. So thank you for the chance. I think I'm going to hand it over back to Grace, if she's there.
Thank you so much, Jemima, for that wonderful presentation. Thank you also for enlightening us about the personally, I've learned a lot. So at this time, I want to welcome Dr. Macharia to continue with additional comments about this wonderful presentation from Jemima. Welcome, Dr.
Good, thank you, Grace. Did you say Dr. Iloka was going to be here?
Yeah, Augustine told me that Dr. Iloka said that he's going to be joining us. He hasn't yet joined. Let me consult with Augustine.
Okay. Thank you so much, Jemima. Biomedical engineering is a very noble, profession. Very noble profession, because engineering is a real fundamental solution for creating health access, all the way from healthy people even through to sick people. When somebody is healthy, you need biomedical devices, for even monitoring, and for like the wearables. And then when somebody gets sick, they rely upon the biomedical devices to make the diagnosis. This is a very broad area, and of course, it's area that is so important. And I'm not sure how much work we are doing for this in Kenya, let's say for in Africa, because it's actually very expensive to do it. And it's almost as if that work, we are not allowed to do it in Africa. This is why I would like to hear Dr. Iloka, because I'm not sure the advances in biomedical engineering in Africa, like what we are doing right now. But what I know is that biomedical engineering is translation science per se, par excellence. Biomedical engineering is translation science par excellence, because first of all, you have to bring multiple disciplines. Like the team, as you've had, would have an engineer, would have some engineers, some doctors, even people in policy, because of discussing policy about human-centeredness, to get to know what is human-centered and what is not human-centered. And so it's a profession that requires you to approach it with a very open mind, because each one of these professions, whether it's engineering, whether it's medicine, and whether it is any other thing that you're gonna need, is densely, it is very deep. It's very deep science. I can't imagine how you can have all the knowledge in medicine and then electrical engineering also at the same time. So it occupies a lot of your cerebral cortex. So that said, that either you have to have the room in your brain to store all that, or you also have the room to coordinate. Like at what point do you get doctors involved? At what points do you get electrical engineers? But at the basis of it, you need to know that basic science. So, for example, in medicine, basic sciences, including physiology, biochemistry, and human anatomy, a biomedical engineer has to understand those things, even so that when you're having conversation with a physician, then the conversations make sense, because you cannot know what to say if you do not understand the subject. So it's very tough. Then, of course, when it comes to engineering, you have to understand, the principles of mechanical engineering, and electrical engineering. Yeah, so it becomes real serious. And of course, material science, because there's material engineering. And then it gets even deeper when you now come and talk about tissues. Tissues has been cell biology, cells, how the cell, because cells form tissues. That means you need to understand biology very well. And now this is coming even to genetics. So I think it's a very deep science, but when you understand it, you're able to be very effective and make some life-changing equipment. And then of course physics for basic sciences, in you'd say making something like an MRI, I feel that is pure physics. So, and then you see the understanding physics, and then how you can use physics in the human body. So these are subjects that are very, very important to understand. And then of course there's still chemistry. So you could say this is high science without doubt. So what we are concerned about here is how you put all those different, you could say, professional disciplines together in one component. You compose it to create an innovation. Because to innovate, it means that you get information from all these disciplines and put them together. That's usually what's very expensive. How do you organize that? That takes a lot of money. And I'm thinking that to create a device, say a biomedical device, for example, a device is going to be monitoring, say, blood sugar. That's called a glucometer. A glucometer is, you could say, when it's in the hospital, like a simple device. Before the glucometer was made like a handheld device, they took blood in the hospital. They took blood from your veins, and then they took it to the lab, and then the lab they put it in the biochemistry. Let's say in the chemistry analyzer, they can tell you the blood glucose. Now they have simple glucometers, as you're saying, that you can use at home to check your blood sugar. But imagine if a lot of people who have got blood sugar, particularly diabetes, they also have eye problems. Now, to get a blood sugar reading, you need to take blood from your fingers and then put it on a reading strip, and then insert that strip in the machine. A small handheld device, maybe smaller than a cell phone, and then it reads for you. See, if you can't see very well because you're visually impaired, particularly due to diabetes, how do you deal with that? These are important questions. Like it has to be human-centered, patient-centered. Think about these issues. And what else can you do to overcome such a problem? Like how taking blood without eyesight and putting that blood on a strip without eyesight. And I think a biomedical engineer is the kind of person who would create a complete device that is fully integrated, that you do not need to do all those steps, and then maybe you just put it on a finger, and then it gives you the blood sugar. See that it reads out loud. And then if you can't see because of diabetic retinopathy, you have diabetic eye problems, you can't see, then you want also not to just display the numbers on the screen, but read out loud. So it actually tells you what is the blood sugar today. Yeah. So you can see, first of all, the technology with it has come in order to make it now fully accessible, for users. Even if such a device, say like a blood sugar device, which can read the blood sugar through your skin. Mhm. It means that it is able to set some radiation frequency into the finger, and then it can come now at assess the color. Let's say the color is called. So the color of the blood, and measure it, and then to interpret how much blood sugar is loaded in those blood cells. So, and then it means that you don't have to prick the finger to extract the blood, but you can see the number of the amount of blood sugar by just looking through your skin. Mhm. So then after it has read, then it reads out that for you. Now, if you're a patient, and you can see even looking for blood sugar problems affects mainly even the elderly who cannot even prick themselves. They would have to rely on someone else to come and prick them. But if we have a device that can do that, then you can see, and I think it's quite possible today to have such devices. So the question is now comes to mind, like if you create such a device, say at your laboratory in the university, how do you manufacture it so that you can distribute it to the market? Let's say to sell to as many people as possible. That if someone was to go to the local pharmacy, you can buy such a device. See, that is what we talk about, the distribution stage in translation science. Now, before that can happen, before the device can appear on a supermarket shelf, say at the local pharmacy, so many things have to happen, and those many things involve money. See, for example, initially to even assemble the doctors to bring together the team, you need to have money to incentivize them to come and help you as advisors for the project. How do you raise money to incentivize such people? You call them advisors. Some of them may not want to be paid with money because they are doing there for a goodwill. But then it comes a point where you have to reimburse people for maybe whatever for their daily needs. So assembling the team in the beginning, after you solidified your idea, and then you build a prototype and show them this is what we would like to manufacture. Well, that team is going to help you understand how to make your device human centered, and you can actually do the actual work that you made it for. For example, doctors will tell you, we would like to know the exact blood sugar. We want to get the blood sugar as accurately as possible. You don't want a blood sugar machine that gives you one reading, and then when you check it again, even next 10 minutes, it gives you a completely different reading. So you would like it to be stable because you're going to distribute it out in the community. And then you want to make sure that the readings that the patient is getting or the user is getting from this machine is reliable. Mhm. That somebody can rely on that data to make a decision whether to take a tablet or not. Or even you want to make it dependable, that someone can depend on it. That means that it is whatever is giving you is accurate. So accuracy is important. Now that means it be dependable, and it's not going to be breaking down in a which way, you know, in a time, and so that it will have someone does not have one day you wake up in the morning and then your machine is not running. You say, what's going on? And you can't figure out what to do. Then you have to run to the pharmacy and tell them, oh, the machine is not running. So these issues that the machine is good and stable. So then you make a prototype and then you test it. Mhm. Now, testing means that you're going to test a few people, small group of people. And then you are in the medical world, we do testing by what we call clinical trials, which are very, very expensive. So clinical trials means that you pay people who are going to do for you what they call randomized control trials. That they find a group of people they are going to test your device upon. And this costs a lot of money. And you're doing these clinical trials to obtain data so that you can use that data to go to the Food and Drug Administration and get approval for your device, so it can be used by the patients, or you can use it can used by people, because you are not allowed to sell a device that is going to help people make clinical decisions if that device is not approved. So the approval process becomes expensive because you have to gather a lot of data. And the data one is data. The first data set is, you'd say, it will tell you whether this drug, and they are not the drug, whether this device is actually testing what you're saying it's testing. Mhm. Then, if it is testing what you're saying it's testing, then you have to do another trial. It's not the same trial. You have to say, how accurate is the data? How accurate are the test results that you're getting with this device? Or how accurate is it? Mhm. So that way you're able to eliminate what's called false positives. And then after testing the accuracy, then you test the dependability of your device. That means how dependable is it? Can you depend on those results now to make clinical decision? But then you have to test it in a wider population. And then finally, you test reliability of that device. Can somebody rely on it? Like if somebody was to be caught in a rainstorm, they can't move. Can they take the data on that and then use it, you know, to actually make independent decision and say this device is absolutely reliable on its own? It's going to give you without having and see. Then when you get all that data from all those tests, then you take that data to the FDA, the Food and Drug Administration, and then you get approval to sell your drug in the market. Now that for many devices, it costs anywhere between $200 million and $1 billion, and about 5 to 10 years of research of testing before you're allowed now to distribute it to the masses. I think that you could say the shortest time we have had someone getting an approval is only, say, 3 years. Yeah. But what I'm saying, that process is very, very long and grueling. So, but people still do that. They make devices because once that device hits the market and is fully approved, then you sell so many units of that device, you're going to recover that $1 billion within a year or two. So they say it is worth it to spend $1 billion testing, because the total market value for that device is maybe $10 billion every year if you're able to sell it to the entire market. That means the beginning you can get in, say, a few hundred millions coming in, but at the very total market saturation, you will be getting billions of dollars every year from that device alone. Now, the problem is the beginning. Where does that money come from? Where does $1 billion come from? And that's why we are here. Because this work of translation science, to get it to the distribution stage where you have your device in supermarket shelf, you have gone through a whole lot of money, burnt a lot of money. You don't know whether you shall get it back. It's called high risk money. A lot of people do not want high risk investments. People are risk averse. That's the idea. People really, if you didn't know that If you knew there's going to be an FDA, it's going to take 3 years to get your device approved, then ordinary people tend to give up on that. So unless the money is insured, they don't want to participate in financing. And much worse, now in Africa, we do not even have the technology for raising money for translation science. It does not exist unless somebody has built it recently. So we rely upon grants. The grants themselves are very small quantities of money. As you have heard, the money required goes to hundreds of millions of dollars for testing to get approval. And so to get to that stage would require us to figure out the system for forming capital to fund translation science. How can we raise high risk money to put money on this process so that all this knowledge, creating these devices that you say they're very good, and in fact, they're going to get better and better and better because you have so many technologies that now can do all this work you're doing, particularly even remote monitoring, where, and of course, distributed system that you'll be able to do tests at home, and then that information can go into the electronic health system, get digitized right away, and it's available to the healthcare provider wherever they are remotely. So you soon can get now remote monitoring very easily, but we have to have the money. You have to compose the money to fund that. And that's what this summit is about. The summit we're having in December is that we have to figure out how do we form capital. For example, now if you look at an MRI itself, MRI is a very complex, gigantic, phenomenally. People have spent a lot of money to create that MRI. And that's magnetic resonance imaging. All the science that went in there required a lot of human resources, very high profile, scientists, engineers, physicists, then from different discipline physicians working together. But then even after that MRI is finished, it has to be built, it has to be put in hospitals or MRI centers, distributed throughout. And all that takes a lot of money. What I say, today, we have the technology for forming such capital, which is the decentralized finance. So what this Land One session is about, this Actuate, is first of all to understand the business, what we need to do, what is needed in the market, what knowledge is present already. Then we have to ask ourselves, how do we form capital to finance this knowledge so we can actually have money to translate that science into products that are now available in the market, on the supermarket shelves, okay, at the pharmacy, and your local pharmacy, even in your local hospital. And that is what you're talking about. How do we fund that process? Because that process does not exist anywhere in Africa. And I believe decentralized finance has got the answer to that question. On decentralized finance, now $1 billion project becomes a cakewalk, because $1 billion, to raise $1 billion on decentralized finance, you would use tokens like Actuate tokens. And then if you have a prototype of this biomedical engineered product or the device that you would like to commercialize, then it gets allocated tokens, and then we ask people to buy those tokens through quadratic funding, or even just a plain token sale. Because it's now the token sale itself, they remove the risk, the financing risk that was there in the traditional finance. How is the risk removed? Because people are risk averse. So when you're holding tokens that are pointing to a device, the device and the token are distanced from one another. They're on the same spot, because the token itself it's another innovation. It's in the market, and in the market is able to do things all by itself, particularly go to a liquidity pool. But it does not interfere it does not rely on its profitability of the token itself. It's not tied to the profitability of the device, which was a big quagmire in the old financing system. That device had to make profitable in order for the billion-dollar investors to make money. But now, with the tokens, the device can even make a loss, but the token is still making profit in the market. See that? So the token is, first of all, it becomes a vehicle that enables you to raise money, to fund the translation science, and it washes away the risks, the financing risk, because the risk is removed totally. And we can go into, mathematics, calculation, and explanation of why does the risk disappear when you use token financing, as compared to when you use fiat currency for funding translation science. Yeah. Then, if we understand now this type of token economics and the token environment, how tokens work, then we are going to be able to access a lot of funding for bringing into being these beautiful technologies, these delicious technologies, like biomedical engineering, biomedical technologies that will improve human life. That's what I would like to add about that. Like from the financing perspective, we actually have the solution. Now, these tokens are built on the blockchain, which is another engineering issue. So they're engineers. What makes it difficult or impossible for the traditional finance, fiat currency, to comprehend risk is because it is different from these distributed technologies. The science of building distributed technology is so different from the science of centralized finance, which is centralized. We see that many times. Decentralized technologies require decentralized finance. It's the same science. Decentralized finance now, and that's why it's congruent with they're congruent with each other. Decentralized finance is congruent with decentralized technologies. And so it removes, that is how it's able to swallow the risk or wash away the risk, because both types of technologies are aligned. So I don't know, let's see. I think we could stop there unless there are questions, concerns, or comments.
Thank you so much, Doc. Hello, Doc.
Yes. Can hear you.
Thank you so much for that wonderful presentation. Thank you for or a comment. I make an announcement about the summit. So our summit, the days are nearing. That's the countdown. And if you've not registered for the summit, kindly register. You saw we've given our free pass. That's when you get 5 Actuate tokens. So make sure that you do that. In case of any question about that too, you can DM me for guidance. Also, continue sharing with your networks about the summit so that we may make this event incredible. So I want to give anyone a chance to ask a question also about the summit, about the registration, or even about our today's topic. I have posted the attendance form on the chat box. Kindly make sure before you leave the meeting, you've filled the attendance form. And remember about the Actuate Summit. Remember to post the summit on your networks, and we are going to appreciate that. Hello, Doc.
Yes, I think what I can say about the summit, we are having free pass. I think that's something I'd like to add about the free pass. Now you can attend the summit for free on condition that you get an NFT number. How do you get an NFT number? NFT number, you buy at least 5 Actuate tokens, okay, from PancakeSwap. You go to PancakeSwap, get 5 Actuate token. By the way, 5 Actuate token is just the minimum. You can buy 100,000, 10,000, even 20. And when you get those Actuate tokens, you create a liquidity pool. You know how to create a liquidity pool. If you do not know how to create a liquidity pool, ask Grace. She's going to help you create a liquidity pool. And when you create a liquidity pool, it generates for you an NFT number. That's the NFT number that you use for registration. So, Grace, you can post a registration link to the summit, and but I think people know where to get the Uniswap. I think it's not Uniswap, PancakeSwap.finance. PancakeSwap.finance, you get your tokens and you create a liquidity pool. That is an absolute requirement for you to participate in this, to get in the summit. It is free because the tokens are yours. If those tokens belong to somebody else, like if they belong to, then you would say that you're paying, but you're not paying anything. You are getting yourself tokens, which you already have. But use those tokens to create a liquidity pool. So because it's no use having tokens, putting them in the pocket and leaving them there. They are not going to be of any use to you, nor to anyone else in this world by them sitting in your wallet. They're going to be useful to you by putting them in the liquidity pool, because when they're in the liquidity pool, they're likely to earn you profits. They'll be earning you the transaction fees. Okay, so they get passive income. That means that the larger the pool you have, the greater the passive income. So liquidity pool, remember, is pairing the tokens like Actuate token with another token like Ethereum, ETH, or Binance coin, which is called BNB, okay, or any other one like USDT. So whatever you choose to pair with is up to you, okay? So, but you create a liquidity pool to get an NFT number, because that NFT number is what is going to admit you. It's your right of admittance into this summit. Now, that if you don't do those things, you pay $20,000. That is good too. No, not dollars. 20,000 shillings. Excuse me, $20,000 too much. No, 20,000 shillings, which is about $150. Right? You pay 20,000 shillings. So it is up to you. What do you want? Pay $150, or do you want to pay 5 tokens, which would cost of you about 1,000 shillings, which is like $10. So that means that you're getting 90% discount. And it's much more than that. It's not 90%. You're getting 100% discount because you're not paying anything, because those tokens belong to you. And what else? You are likely to make a profit by just creating a liquidity pool. So you're getting 110% profit for coming to the summit, for doing those things, instead of paying $150. Now, I would think such a thing is no brainer. You take it or you pay $150, because either way, you come at the door at the amphitheater, you have to show the NFT number, and if you don't have it, you pay 20,000 shillings. Which one do you want to do? You see, ask yourself. So, because really eventually, you're getting a very big opportunity to participate in a very, very important event where there's gonna be some real serious people professionals that will guide you and help you advance in your career. Okay. So I think we'll stop there so that we can prepare to go to women in decentralized finance.
Thank you so much, Doc. I have posted the link for the attendance. Also, you can check it out. Sorry, Dr. Iloki didn't make it for the meeting today. He was up in another meeting. So kindly fill the attendance form before you leave the meeting. The meeting is adjourned. Thank you for coming in.
Okay.